Problem 17. What is the area of the region enclosed by the graphs of f of x equals x squared minus 2 and g of x equals x? Alright, so we need to find the area between these two curves, and we don't have a calculator to help us with. So let's just do a quick sketch. We know what these curves should look like if I were to graph them, so let me put some axes up here. And I know that this first curve, it's a quadratic, so it's going to be a parabola, and it's going to hit the y-axis at -2 because when x is 0, that's -2, and it's going to open upwards since I have a positive leading coefficient, so I know that this first curve is going to look something like this. Maybe not exactly, definitely not exactly, but something like this. Okay, that's a pretty bad parabola, but hey, whatever. Okay, second one, g of x equals x. We definitely know what this was. This is the identity line, the line through the origin with slope 1. And now I have a much better idea that they're asking for the area enclosed by the graphs, and now I can see the area that's enclosed by the graphs is going to be in here. Okay, this area right here, this lovely, lovely area. Okay, so all these other areas around here, they're infinite regions out here, so it's not enclosed by the curves. So I notice a few things. I notice that g of x is greater than or equal to my f of x for everywhere that I care about for this integral. And we have a rule that tells me that the area between two curves will be equal to the integral from my starting value to my stopping value. I still need to find those. We'll find that next. Will equal the integral from starting to stopping of the larger function. So the larger function, the greater function in this case is g of x. So g of x minus the smaller function, in this case, f of x. With respect to x. And the reason that this works is integrals find me areas, signed areas, positive or negative, but integrals find me areas. And basically what this does is it sort of, I don't want to say normalizes it, but it sort of says, okay, I have this height, the distance between g of x minus f of x, somewhere along here. And if I had a very thin rectangle, that dx wide rectangle, that infinitesimal wide rectangle, I could find its area by taking g of x minus f of x, that's the height of the rectangle, and then I have the small width. And so if I integrate along or line up a whole bunch of these super thin rectangles, I'll fill up this area and I'll get my answer. So that's that. Next thing. We have the two endpoints. We have this A and this B. If we had a calculator, we could graph it and do the intersection. We don't have a calculator. But I know that these will intersect when f of x is equal to g of x. It's a nonlinear system of equations. Actually a pretty easy one too. So I want to find out where they intersect. I want to find out where f of x is equal to g of x. I need to find the x value that happens. So let's just set them equal to each other. F of x equals g of x. I know that f of x is x squared minus 2. I know that g of x is x. And this is looking pretty good. I have a quadratic equation, so let me move this x over here by subtracting. I will get x squared minus x minus 2 is equal to 0. And nicely enough, this factors as x plus 1 multiplied by x minus 2. And by the zero product property, I know that x plus 1 equals 0, so either x equals negative 1, or x minus 2 equals 0, so x equals 2. And those are my two endpoints. If you're not sure about it, you could try to put a negative 1 into both of these. Negative 1 squared is 1, minus 2 is negative 1. X, negative 1, they're equal. And if you put in 2, 4 minus 2 is 2, which is equal to 2. They works out to where they are equal, where they intersect. So now I can use all of this information. So this will be my A value. This will be my B value. That's the negative 1. That's the 2. And I can go ahead and start to evaluate this integral. So the integral, so the area is equal to the integral from negative 1 to 2 of g of x. My top curve is going to be x minus f of x. My bottom curve is going to be x squared minus 2 dx. And before I do the antiderivative, let me clean up these parentheses a little bit, distribute through this negative sign. So that's still going to be equal to the definite integral from negative 1 to 2 of. I'll have a negative x squared plus x plus 2 dx. Okay, and now just need to take the antiderivative of this, which will give me x cubed over 3, so I have a negative x to the third divided by 3. X squared over 2, so plus x squared divided by 2 plus 2x. And since I'm doing a definite integral, I don't need a plus c, but I will have this entire thing. Sometimes they like to show it with brackets, but I like this notation a little better, from negative 1 to 2. So just got to finish this up. It'll take a little while by hand, but we can put everything in. So let's see, I'm going to have to put in the 2, put in the negative 1, and subtract those. Let me say, okay, 2 cubed is 8, so I have negative 8 thirds. 2 squared is 4, divided by 2 is 2. 2 times 2 is 2, or 4, sorry. Ooh, that was almost really bad. Luckily I didn't say that. You forget I almost said that, okay. Minus, put in the negative 1. Negative 1 cubed is still negative 1. Times another negative sign gives me a positive 1 third. Negative 1 squared is positive 1. Divided by 2 is 1 half. And 2 times negative 1 is negative 2. Okay, what's the easiest way to take care of this? I think it might be easiest to start combining some like terms. So this negative 8 thirds minus 1 third gives me negative 9 thirds. That's wonderful because I get rid of thirds. I get into integers. This 2 plus 4 plus another 2 minus a negative 2. 2 plus 4 minus a negative 2 plus 2 is 8. And then I have plus 1 half for this last one here. Let me do a little bit nicer color with that. So let's use blue. So we have this plus 1 half. I've taken care of all of the terms. Now, negative 9 thirds is negative 3. So negative 3 plus 8 is 5. Plus 1 half is 5 and a half. I hate mixed numbers, but I figure out right here because this then... Ooh, I messed up. Someone should have caught it. Hopefully you guys did. minus 1/2 was negative, which means I don't have 5.5. I have 5 minus 1/2, which gives me 4.5. That's looking nice because I see an answer up here that matches up. 4.5 is the same as 4 is 8/2 plus 1/2, 9/2, and my answer is B. And forget all those mistakes I made, okay? Alright,